functions, like I said yesterday, this is stuff that we did in Algebra 2. We're just going to refresh on it a little bit today. Things are in logarithmic form if they have the word log in them. So first thing you need to write is log base b of n is equal to e. That's logarithmic form because it has the word log in it. Those b's, e's, and n's are going to stand for things, and I'll remind you what they stand for in just a second. Then what we're going to do with logarithmic form is go back and forth to exponential form. Exponential form says b to the e is equal to n. That's exponential form because it has an exponent in it. That is some deep stuff. Log form has a log. Exponential form has an exponent. I mean, I don't know if y'all can handle that or not. I'm not real sure. Purpose of log functions are to be able to solve when your variable's in an exponent. You just did that on the bell ringer. But what makes it difficult is that all the time you're not going to be able to do like you did on the bell ringer because you're not going to be able to get same base all the time. That's when you'll have to go to log functions. Okay? That's right. Our good buddy Ben. The B stands for the base, the N stands for number, and the E stands for exponent. Make sure you know that E stands for exponent because next week we're going to look at the number E, and that's totally different. The number E is different than this letter E that stands for exponent. Yes, there is a number E. We did it in Algebra 2. All right. Those B's, E's, and N's, they're interchangeable in both of those forms. It's the same B in log form and in exponential form. It's the same N in log form and in exponential form. But be careful because they're in a different order. Okay, on log form, it's B, N, E, but then in exponential form, it's B, N, B, E, N. So make sure you're aware of the different order that they jump around to. Okay? First thing we're going to look at here says log base 3 of x is equal to negative 3. And our directions say to solve for x. Now, log base 3 of x is equal to negative 3. What form is that in? Log form or exponential form? Log, because it says log. Very good. You are catching on. So what we'll do to start solving when that's in log form is to rewrite it in exponential form. So I got to have a b, an e, and an n. So looking at log base 3 of x, what is my b? What's in the same spot as the b?
3.
3. Everybody see where Chase is coming on that? Good job. What is my e?
Negative 3.
Negative 3. What is my n? X. So we'll write 3 to the negative 3 is equal to x. And then we just got to figure out what 3 to the negative 3 is. We know when we have a negative exponent, it goes on bottom and becomes positive. So this is the same as 1 over 3 cubed. 3 cubed, 3 times 3 is 9, times 3 is 27.
Students to the high school office, Sydney Donaldson, Braden Carmen, Hunter Hilton, Tim Haney, Janae Guthrie, and Elena Guthrie.
So you eventually are going to see that x is 1/27. Here we go. All right, any problemos or questions on that? All right, let's look at one that adds another step or two. Everybody got what we need on that one? It's finally all showed up there. We're good? All right, this one says, maybe, there we go. This one says log base 1/3
I'll get it.
of 2x plus 5 is equal to 2. Okay, so my first question is, am I in logarithmic form or am I in exponential form? Right, even though all the stuff hasn't showed up, it's still log form because it's got log written. So, I don't know. So, we're going to rewrite it into exponential form. So, what's my b? What's in the b spot?
1/3.
1/3. What's my e?
2.
2. Now when I square that, I'm going to put my 1/3 in parentheses to remember to square top and bottom, is equal to, what's my number?
2x plus 5.
2x plus 5. So that whole piece is the number. That's what made that a little bit different, but it's not any harder. Now to start simplifying this to solve for x, you need to first off do that squared over there. So I'm going to square 1/3 which means I square numerator and denominator. So that'll mean 2x plus 5 is equal to 1/9, right? Now I'm trying to get the x all by itself. What would my first step after that be to do to get the x all by itself?
Add 5.
Close.
Or subtract 5.
Subtract that 5. Good job. And that's going to turn into something ugly. What is 1/9 minus 5 in fraction form? Negative 44/5, 44/9.
Negative 44/9.
44/9. Thank you, ma'am. And then what's your last step?
Divide by 2.
Divide by 2. That would be negative 22/9. Shazam. Alright, got a couple more of those. That good? Alright, here I've got log base x of 5 is equal to 4. Log base x of 5 is equal to 4. Real quick, I want you to rewrite it in exponential form. Don't have to worry about trying to solve it yet, just rewrite it into exponential form real quick. Now, what'd you get? What's your exponential form say?
X to the 4th is 5.
Not a kid. No, I wrote 5. X to the 4th, just like Chase said, is equal to 5. And now this one presents a new dilemma here. I'm trying to solve for x. It's being raised to the 4th power. How do I undo a 4th power? 4th root, very good. So remember when you do an even root, it can be positive or negative. What is the 4th root of 5? It's irrational, isn't it? There's not a perfect 4th for 5. So if you type that in your calculator, it's going to be something that keeps repeating forever. So you actually just get to jump ship and stop there. Alright, one more that's the hardest of these kind, then we'll look at the next phase. I got what we need? I got log base 36 of the 4th root of 6 is equal to x. Alright, so what will our exponential form look like?
36 to the x
Yep. Is equal to?
4th root of 6.
Uh-huh. Good, okay. Good, Kaylee's got that rewritten in exponential form. Now, this is where we're going to have to pull on some past knowledge because I'm trying to solve for x and there's nothing I can really do there. But I can rewrite the 4th root of 6. Remember, with exponents and radicals, it's the same as power over root. Power over root, remember that? So the 4th root of 6 is the same as saying 6 to the 1/4 power. Right?
Yes.
So now that takes us back to the bell ringer in yesterday's work. What base could I create there that 36 and 6 could share? 6. Very good. Y'all got it. So 36 will be 6 squared, and there's an x up there. 6 to the 1/4 already has it, so you don't have to change it. So just like yesterday, 6 equals 6. So 2x has to equal 1/4, 1/4. How do we solve that for x? Add a kid, divide by 2. What's 1/4 divided by 2? Not 1/2.
1/8.
An 8. Good. A division with fractions. Still confusing all these years later. Alright, Move next phase now, and these are pretty easy. I'm going to show you some special cases and teach you how to use the calculator all at once. You actually have done this on your calculator in Algebra 2. I just got to remind you of some things. I got log base 12 of 12, log base square root of 3, square root of 3, and then log base 3 of 1, and log base 0.4 of 1. Alright, so first off, grab a calculator if you got one around. The far left side next to the 7 is a log button. See that? That only works if it's log base 10. Okay? Log base 10, and we're going to talk about next week, is called a common log. That log button next to 7 only works then. I've got log base 12, so that button does me no good right now. But I can hit math and scroll it all the way down to where the letters are, and I think it's letter A. It says log base. Yep. Unpick that and fill in the blanks. Mm-hmm. Now, I was looking over Caitlin's, so I just disconnected something. I was looking over, I don't know what I just did, Caitlin's shoulder, and she's got 1. Is that what everybody got? Yep. Okay, so that's pretty cool. I want to talk to you about that, about why this is a special one, and we'll see what's cracking with it. If I were, this is log form because it says log. If I were now to rewrite this in exponential form, my base to the exponent is equal to the number. So that should make perfect sense now, right? Anything to the first power stays what it was. So your mental note and shortcut is when your base and your number are the same, it's going to be 1. So what's this one going to be? 1. I had a kid. Okay? Check this one now. See what log base 3 of 1 is. Math, log base 3, 1. Everybody got it? Evan's giving me the big fat not 0 there. Make sense? Look at it in exponential form. Base to the exponent is equal to the number. What's anything to the 0 power?
1.
1. So anytime you're looking for a number of 1, it's going to be 0. So what's this one going to be? Okay. So those are some special cases in log functions, and you got refreshed on how to find them in your calculator all at the same time. Good on that? So you could do log base 12 of 78. You know, you could do it. I don't know if that works or not. You could do anything like that. All right, the last thing we're supposed to cover with this is graphs. So I want to look at a graph real quick. This one says log base 1. Oh, let's do that. Log base 4 of x, f of x is equal to log base 4 of x, and you're told to graph. You know, 98% of the time when I'm graphing, the very first thing I do is make an input-output table. Pick some x's, plug them in, and solve for y's. This falls in the 2% when I do not do that. If I'm graphing a log function, I automatically go to the calculator for my graph. So make sure, and somebody first period couldn't get this in their brains, make sure you go to y equals, because the directions said graph. Anytime it says graph, you go to y equals. So in your y equals menu, then hit math, pull up log base and fill in the blanks. You get something similar to that? Not too bad on that? You did or didn't?
That's good. Okay, I got it.
Alright. Now I want you to notice if I read that left to right, even though it's not as pronounced as the exponential functions that we did yesterday, that does go uphill, right? If you read it left to right. And my base was 4, right? So this is like 4 to some number. So bigger than 1. Y'all had that yesterday. It went up. Okay, what if we did f of x is equal to log base 1/10 of x? Left to right, what should I expect to see? It's going to go down. Very good, Aaron, because 1/10 is smaller than 1. Okay, hit y equals, go graph it and check it out. It ends up being almost like a reflection, almost, doesn't it? Did I get it? Check it out and see if you got it. If you need help finding anything on the calculator, let me know. If you look at your table on these things, and this is why I said 98% of the time I go make an input-output, this 2% I don't. If you look at your table, you get some ugly, stinking answers, values in there, don't you? That's why it would be a lot more, wouldn't be undoable, but Zane tried to be a lot more difficult to do these with an input-output table. Calculator saves you a little bit of time on that. You have to do a lot of rounding and all that kind of stuff. All right, what we've got cracking next. Tomorrow I've got an assignment for you. I'm going to do that tomorrow. Still got lots of log stuff left. I had originally told you end of next week would be test. End of next week we'll get study guide. And then test will be the beginning of the following week. Okay? Does that make sense? Everybody all right? All right, I didn't do an exit question again today. I'm getting lazy. I didn't do it again today. That's it.